Hi, I'm Miss Hearn. Let's get started. In this video, we're going to continue talking about systems of linear equations in two variables, but we're going to focus on those kinds that include or involve percentages. So we're going to do a couple of problems just to get warmed up, so to make sure that everybody's comfortable with percentages. So for example, if I asked you to find 40% of 96, one thing to remember about percentages is the word of is going to always mean to multiply, and that we use the decimal form of the percent. So when I say find 40% of 96, this is the same as the arithmetic operation 0.40 times 96. Multiplying 0.40 times 96, we get 38.4. So 40% of 96 is 38.4. If I asked you what percent of 28 is 14, then you have a little bit of an equation to solve. The missing quantity is the percent. Let's call that x. X percent of 28 means to multiply x times 28, and is means equals, so x times 28 is equal to 14. So you just divide 14 by 28 to get x by itself. 14 divided by 28 in decimal form would be 1/2, 0.5. Now this is the decimal form of the percent, so we would, to rewrite it in a percent form, move the decimal 2 places to the right, and that means 50%. So doesn't that make sense though? 50% or half of 28 is equal to 14. All right, and then another question involving percentages, 20% of what number is equal to 32? So 0.20 times, of is times, what number, so the missing number is x, is equal to 32. So we have a little equation to solve again. So 0.20x equals 32. We can solve by dividing both sides by 0.20. So x is going to be 32 divided by 0.20. 32 divided by 0.20 is 160. Okay, so does that make sense? Does 20% of 160 equal 32? You can check that by just multiplying 0.20 by 160, and you'll see that yes, it does equal 32. All right, so those would be your basic problems involving percentages. Let's look at an application. It's not a system yet, but it's an application involving percentages, and then we'll solve an application that does involve systems of equations in the same context. So suppose that an engine uses a mixture of water with pure antifreeze. At moderate temperatures, a 50-50 mix is appropriate, 50% water, 50% pure antifreeze. When the temperature drops below 32 degrees Fahrenheit for a long period of time, though, a mixture of 70% antifreeze to 30% water is better. We're going to use this information to answer some questions. So, if a typical radiator holds 8 liters of fluid, how much water and how much antifreeze should be mixed in order to fill the radiator of a car driven in a moderate climate? Well, we said that in a moderate climate, we want 50% water and 50% antifreeze. So we're really saying that the amount of water should be 50% of 8 liters. Well, 50% is half, right? So you could multiply it out in decimal form, 0.50 times 8, or you can just think of half of 8 would be 4 liters. Similarly, for the amount of pure antifreeze, we're still finding 50% of 8, which is the other 4 liters. So 4 liters of water, 4 liters of pure antifreeze. If a typical radiator holds 8 liters of fluid, how much water and how much pure antifreeze should be mixed in order to fill the radiator of a car driven in a climate which drops below 32 degrees Fahrenheit for long periods of time? Okay, so we were told that we want a 70% antifreeze to 30% water mixture. So let's find the amount of antifreeze. It's going to be 70% of the number of liters that it holds, which is 8. So multiplying 0.70, the decimal form of 70%, times 8 liters, we're going to get 5.6 liters of antifreeze. And then how much water? Well, that's 30%. You could get that by subtracting, by the way, 8 liters minus 5.6. But let's do it this way, just to practice our percentages. So 30% of 8 liters is the same as multiplying 0.30 times 8 liters, which is going to give you 2.4 liters. And notice those add up to a total of 8 liters. All right, one more. Suppose that you move from a moderate climate to a cold climate and you decide that you need to change from a 50-50 mix to a 70-30 mix of pure antifreeze and water. How much of the 50-50 mix should be drained and replaced with pure antifreeze to increase the percentage of antifreeze to 70%? Okay, so the way I like to think of this is we're starting with a certain number of liters of antifreeze in the engine. And we're taking away some, so we have a certain amount of liters of antifreeze that we're removing, adding some back in, more than what we took out. The same amount of fluid is coming out, but and going back in, but the fluid we remove has half as much antifreeze as the fluid we're putting back in. So we want to keep track of how much actual antifreeze is going back in, and then we're gonna if you add that up, you get the total number of liters of antifreeze that they're gonna be in the engine in the end. So let's think about how much antifreeze we're starting with. So we're starting with a 50-50 mix, and we know there's 8 liters in the engine. So 0.50 times 8 is the amount of liters of antifreeze that we're starting with. We found this before. There were 4 liters of antifreeze in the 50-50 mix. Okay, and we're going to take away a certain number of liters of antifreeze. We don't know how much that is, but I'm going to pick a variable to represent the amount of liquid that I'm removing, the number of liters of liquid. I'm going to call that R. R equals number of liters removed, liters of liquid. So this includes any water or antifreeze that's in the mix. So if R is the number of liters removed, how much of that is actually antifreeze? Well, since we're removing a 50-50 mix, what we're removing is 50% of R in liters of antifreeze. So let's say, for example, we end up taking out 2 liters of liquid. That's actually just 1 liter of antifreeze since it's a 50% mix. And then we're going to add back in that liquid. And when we add it back in, it's 100% pure antifreeze. So 100% of R, or 1 times R. You don't have to write that, but just to emphasize that it's 100% of it that's pure antifreeze being added back in. And then in the end, we want to have a 70% mixture, 70-30. So 70% of the 8 liters of liquid is going to be antifreeze. So we have 4 liters minus 0.5 R liters plus R liters is going to be equal to, and remember that turned out to be 5.6 liters of antifreeze out of that 8 liters total of liquid in the engine. I'm going to erase the L so it's a little more clear. Okay, so in this case, we only have one variable that we're solving for, R, and we can actually combine like terms here. So negative 0.5 plus 1 is going to give us a positive 0.5. So the equation looks like 4 plus 0.5 R equals 5.6. Subtracting 4 over to the other side. Let me go ahead and scoot over here so we have a little more space. So we're going to subtract 4 over to the other side, and we're going to have 0.5 R equals 5.6 minus 4 is 1.6. Then we're going to divide both sides by 0.5, which is the same, by the way, as multiplying by the reciprocal too. So that means that R is going to be equal to 3.2 liters. So we're going to take out 3.2 liters of the 50-50 mix, and we're going to put back in 3.2 liters of pure antifreeze in order to end up with the mixture that we want, 70-30. Okay, remember, if I'm going too fast, you can always pause, rewind, and so on. And if I'm going too slow, you can watch it on double time speed, get through it faster. Okay, so now with that in mind, we've practiced finding percentages, and we've practiced doing an application problem involving percentages. In this same context, let's look at what would end up being a problem where we could use a system of linear equations to solve it. This is called a mixture problem, and we have suppose that the driver had to completely drain the radiator and replace, it should say just all 8 liters of the antifreeze mixture. If she has a bottle of 60% antifreeze solution and a bottle of pure antifreeze, how much of each should be mixed to fill the radiator, this should say 2, to fill the radiator with 70% antifreeze? Ooh, a lot of typos. Okay, so what we want to start with, think of it as we're going to start with something that we'll put in. We're going to add something to it plus the amount that we add, and we're going to get what we end up with. I know that sounds kind of silly, but that's how I think about it. So let's say that I start by putting a certain amount of the 60% antifreeze, and then I add to it some pure antifreeze to get what I want to end up with, which is the 70% solution. So we can think of it as two unknowns. We don't know how many liters of the 60% solution we're going to start with. We don't know how many liters of pure antifreeze we're going to add. And we definitely know, though, that we want to end up with a 70% solution that has a total of 8 liters, filling the whole tank. So there's always going to be, when you think of it this way, there's always got to be 2 ways to relate the x and the y to give us a system of 2 equations. And usually one way to relate them is to think in terms of just the mixture of liquid altogether. In other words, counting all of the liquid, the water, and the antifreeze. And then another equation or relationship comparing just the liters of antifreeze. Okay, so let's talk about just liquid. Forget about the percent that's antifreeze for a minute. We're going to start with X liters of liquid, and we're going to add to it Y liters of liquid, and we're going to end up with 8 liters of liquid. Now, another relationship is the amount of antifreeze that we start with plus the amount of antifreeze that we add to it is going to equal the amount of antifreeze in the end. So how much antifreeze is in the X liters we're starting with? Well, that's 60% of X, or 0.60 of X. 60% of it is antifreeze. Plus, how much antifreeze is going to be added to that? Well, we're adding pure antifreeze. So all Y liters. You can think of it as 100% of Y. 1.00 times Y would be the decimal form of 100% times Y. Or you can just write y, because 1 times y is just y. And then we want to end up with 70% of 8, which we already said before was 5.6. So we have two relationships. That's what constitutes a system of equations. And it's a system of linear equations because there's no x squareds or anything weird. And it's two unknowns. So two equations will be sufficient to find the values. So we have x plus y equals 8 would be equation 1. And equation 2 is 0.6x plus y equals 5.6. So we're going to use the same technique we did in the previous video for example 1. We're going to use the addition method. And so right now, if I added the two equations together, nothing would cancel out. We need one of the variables to cancel. That's what the addition method is all about. So what I'm going to do is I'm going to say, oh, what if I wanted the y's to cancel? I could multiply one of the equations through by a -1 and add it to the other. It doesn't matter which equation, but I'm going to choose to multiply the second equation by -1. So the first equation I'm going to keep the same, x plus y equals 8. And the second equation will, distributing that 1 through the whole equation, -0.6x minus y equals -5.6. Now we're going to add the two together, and we're going to get 1x minus 0.6x is 0.4x. These two add up to 0, so we don't need to write anything. And then 8 minus 0.56 is going to be 2.4. Now we just need to solve for x. So 0.4 times x, to reverse that we divide. So we get x equals, and 2.4 divided by 4, let's see, that's the same as 24 divided by 4. So that's going to be 6. So x equals 6 liters. That's the 6 liters. Remember, we said that x was the liters of 60% solution. So we just found that we need 6 liters of the 60% solution. And then we need to figure out how many liters of the pure the pure antifreeze. Well, we know that x plus y has to equal 8. So plugging in 6 plus y equals 8 would mean y has to be 2. So we have y equals 2 liters of pure antifreeze. So I hope you found this video helpful. If you did, please remember to give it a thumbs up. That helps other students to find the video.